In the last class, we were discussing the generation of EMF in a coil. We derived the equation of EMF E is equal to EM sin omega t, where the maximum value EM is equal to N into phi m into omega. EM is equal to N into phi m into omega. We know that the maximum flux density Bm is equal to phi m by A, or phi m is equal to Bm into A, where Bm is the maximum flux density and A is the area of the coil. So we can substitute for phi m in the maximum voltage equation. EM is equal to N into omega into, instead of phi m you can write Bm into A. Omega is equal to 2 pi f. So EM is equal to, instead of omega you can write 2 pi f N as it is, then Vm into A. That is the equation for maximum voltage induced in a coil, where N is the number of turns, F is the frequency, Bm is the maximum flux density and A is the area of the coil. Similarly, you can write I is equal to Im sin omega t, where Im is the maximum value of the current. Coming to different terms associated with AC. First, we will discuss waveform, what a waveform is. Here we have I have drawn a waveform of voltage. Waveform is a graph obtained by plotting instantaneous values of voltage or current on the ordinate against time on the abscissa is called a waveform. That is, here for each instant of time we are taking the instantaneous values of the voltage, and a graph obtained by plotting all the instantaneous values, we will get a waveform. This is the voltage waveform. Now coming to instantaneous values. The value of an alternating quantity at any instant of time is called instantaneous value. Generally, lowercase letter e or I are used for representing instantaneous values. Here you can see the instantaneous value at instant t equal to 0 is equal to 0. The EMF value is equal to 0. This is the instantaneous value at time t equal to 0. Here at this time, the value of the voltage, the instantaneous value of the voltage is maximum, that is EM. At this instant, the value is equal to 0. Like that, at any instant t, you can find the instantaneous value E using the equation Em sin omega t by substituting for the value of Em and t. You will get the instantaneous value of the voltage E. Now coming to cycle. One complete set of positive and negative values of an alternating quantity which repeat at regular intervals of time is called a cycle. Here, one complete set of positive and negative values, that constitutes a cycle. This is one cycle of EMF. Now coming to time period T. The duration in seconds of one cycle of alternating quantity is called time period. Here you can see from here to here the time taken to complete one complete cycle. That if it is t seconds, t is called the time period of this waveform. Now coming to frequency. Frequency, that is represented by F. The number of cycles per second of an alternating quantity is called frequency. On the x-axis, if you are taking time t, here it is omega t, or you can plot as t as the abscissa. The number of cycles per second of an alternating quantity is called frequency. F is equal to 1 by time period. Its unit is hertz. If you know the time period, you can calculate the frequency like this, 1 by t. Now coming to amplitude. The maximum value of an alternating quantity is called its amplitude or peak value. In this case, you can see that the maximum value of an alternating quantity or one complete cycle, its value is equal to Em, the maximum value. Here also you have Em. So the maximum value of this sinusoidal quantity is Em.